I'm going to answer some questions that you guys had on the practice test. So number 11 asks which compounds has resonance structures. If you draw those out, you'll find that letter A, C6H12 is benzene. And if you recall from when we discussed resonance structures, benzene was one of them because of the rotating double bonds. It could be written like this or like that. So that was letter A. On number 14, it shows an enthalpy diagram. So this is kind of like a Born-Haber cycle that is mostly covered in HL. But basically what you're doing is that you're looking at the arrows in which side of the diagram they're on. So if you're looking for Y, you would take these two values on the left side and you would add them, negative 77 and negative 286, and then you would subtract what you see on the other side. So you would subtract negative 1,301. So the answer there would be negative 788 minus 286 plus 1301, right? It's basically, again, like I said, taking those two values, adding them together, putting them together, and then subtracting this negative 1301 is the same as adding 1301. So the answer there is letter A. On number 17, it shows a graph and it says which set of conditions will most likely give the data plotted on graph 2. So graph 2, notice that it rises faster. And then, of course, they both reach completion at the same time. So, but what would cause the reaction rate to be faster? And so of the options listed, it would be that the smaller the lumps means that there's going to be greater surface area. So that narrows it down to either B or C. And then the concentration of the acid, the higher concentration, 1.0, is going to make the reaction go faster. So the correct answer there is letter C. Smaller lumps and higher concentration of the acid. For number 25, it asks which compound can both be esterified and turn acidified potassium dichromate solution green. So what I did is that I looked up esterification. So for esterification, you have to have a carboxylic acid and an alcohol. And turns out that you need the carboxyl group of a carboxylic acid. So I drew all 4 of those molecules out. And so this is what I got. Okay, so look, I have the first one is a tertiary alcohol. You can draw it and look at the formula that's given so you can verify. The second one, I drew it out and I got a carboxylic acid. Okay, remember our functional groups from topic 10. Double bond O, OH. The third one is a secondary alcohol. And the last one is a ketone. So, based on the definition of esterification, which says that it requires a carboxyl group from a carboxylic acid, I deduced that the only correct answer could be letter B, because it's a carboxylic acid. For number 28, looking at this graph, I can see that because it's a linear graph, it is going to be proportional. So that means that it's going to be either A or C. And then the fact that it's a graph that's going negative, it has a negative slope. The correct answer is letter C. Y is proportional to negative X. For number 29, it says which feature of a molecule can be determined from its H-NMR spectrum. If you look up H-NMR spectrums, and I'm pretty sure we've watched videos on it before, and if not, I'll look up a video and I'll post it on the classroom so you guys can look at it. The correct answer for that is letter A. It's the number of hydrogen environments. In other words, you're able to determine how many different types of hydrogens are in the particular molecule by looking at an H-NMR spectrum. Finally, I got an answer on number 30. A question on number 30. And so if you look up what the index of hydrogen deficiency means, it means how many H2 molecules are required to fully saturate the compound. Okay, so again, I wrote this down. The index of hydrogen deficiency means how many H2s are needed to fully saturate the molecule. So then what I did is I drew them all out. So the first one, remember C6H6 is benzene. How many double bonds are there? 1, 2, 3. That means you would need 3 H2s to fully saturate benzene. The next one is C2Cl2. There's a triple bond in between the two carbons. So to break those two bonds, you would need 2 H2 molecules to fully saturate that molecule. The next one is C4H9N. When you draw that molecule, you find that there's going to be a double bond between the C and the N. You need only one H2 molecule, one H2 molecule to break that double bond and fully saturate that molecule. So that has an index of hydrogen deficiency equal to 1. So notice this one has 3, this one has 2, this has 1. And the last one, letter D, it's an alcohol, C2H6O, and that one has no double bonds. So this one's already fully saturated. That means that the degree of, the index of hydrogen deficiency for this one is 0.